Hello and welcome back to Getting Started with BGFX. Now in the last video I said we will do a 3D rotating coloured pyramid, but a few people have expressed an interest in getting ImGUI running. So I thought, why not wait? Let's do it in this video. Now ImGUI is a very popular graphical user interface library. It's open source, you can download it from GitHub. We've already included it in our project, and it has a huge number of widgets that you can use. And it is designed to work with any window manager and any rendering library. You just have to provide the right backends. So you need a backend to translate the events generated by your window into events that ImGUI can understand. And then you need another backend to translate the draw lists that ImGUI generates into render commands that your renderer can understand. ImGUI already comes with a backend for SDL3 by default, but it doesn't have one for BGFX. Now, the BGFX repository does have one deep down in the example code, but I don't like to use it. So I created my own, and it's already included as part of our project, and I'm making it freely available for anyone to use. But before we dive into that, I just got a shout out to a few people. First to this guy, Branimir Karadzik. I probably just butchered that name, but this is the creator of BGFX, and he has included this tutorial series and repository as part of the official documentation. So if you go into the repository and then go to its website, go to the API reference, and there it is, links to the series and the GitHub repository. Next is over here. This is Gendrik Illner's weekly newsletter, graphics programming newsletter. Going to his bio, he's pretty big in the graphics programming world, and he's included this series as part of his newsletter. And finally, to all you lovely people out there in YouTube land, for all your likes and subscriptions and your wonderful comments, I am now up to 95 subscribers. So thank you very much. Keep those likes and subscriptions rolling in. Alright, without further ado, let's get into some code. So if we go into our project, now before we get into it, I just want to do a bit of organization that will make our job easier in the next video. We are going to spread all of our work across multiple IDs, and the 3D has to be done in its own view, and ImGUI has to be done in its own view. So rather than rely on magic numbers, let's define our view numbers. So we go to the header. First thing to do is we will define our 3D view, make that view 0. We'll define our 2D view, make that view 1. We will define our render view, make that view 2, and we will define our ImGUI view, make that 255. Alright, let's go to the renderer source code, and we will update our numbers to use these definitions. So there's nothing there, so if we go to this, that's our 2D view, that's our 2D view, and that's our 2D view. And then we'll scroll down to here. That's our view, that's our stream, that's the slot number. So we'll submit that to our 2D view. Then we'll do the same for our render view. We'll go back up to the top. Render view. Nothing needs to be done there. Nothing needs to be done there. That's the stream. And nothing done there. Nothing done there. Alright, so let's run this. And as you can see, nothing's changed. So what we've done is we've just given the views names, and what ImGUI does is, what BGFX does is when it renders everything, it starts at view 0 renders the 3D, view 1 renders the 2D, view 2 renders everything, and then finally renders ImGUI on top of everything. Alright, let's get ImGUI running. So we'll go into our main code. First thing to do is we need to include the ImGUI header file, and then we need to include the backend for BGFX for SDL3. Impl SDL3. Okay, so after we've created the window, we need to create the context, and then we need to initialize it for other. So we'll just feed it the window. We're saying other because by default it doesn't come with an initialization function for BGFX. Now inside of our main loop at the very top, we need to start a new frame. And inside of our event loop, we need to process the event. So we give it the pointer to our SDL event, and then we'll start our new window. So we can actually, let's do it after we've drawn everything. So we can just go ImGUI new frame, then we'll start a window. We'll just call it window, and then we need to end the window, and we need to we don't need to show everything down here, but we do need to do it in the renderer. Alright, let's pop on over to our renderer. So I'll go at the top. Need to include, just for completeness sake, include the ImGUI header. Then we need to include the backend for BGFX. Excellent. Now in the initialize function, we'll go right down to the bottom. We need to initialize ImGUI for BGFX. And then we need to pass it the view ID that we're using. Alright, now inside of our begin, we need to call the new frame. And then in our render, before we call the frame, we need to draw everything. So we go ImGUI underscore impl underscore BGFX render draw data, and we need to get the draw data from ImGUI. Alright, that's how you do it. So we'll run it. Oops, what happened here? Oh, sorry, I missed a line. Before we render the draw data, we need to call the render function itself so it generates all of our draw lists. Alright, so we'll run that again. And up here is our window, so we can move it around, we can expand it. It's drawn on top of everything. Excellent. Alright, so what we're going to do now is we are going to have a color picker that sets the post-processing color. So the first thing we need to do is we need to go back to our header file. We need to, this is our NDC vertex buffer. This is the vertex buffer that BGFX uses to draw to the screen. We need to turn it into a dynamic one because we're going to set the color per frame. So now that we've done that, we need to go up here and we need to create a dynamic vertex buffer. And of course we need to call the update function. And we'll do the need to update it with the NDC vertices. And we'll just make sure that's still working. Which it is. Fantastic. Okay, so what we need to do now is we need to create a new function to set the post-processing color. So we'll create it here. We'll do the definition, set post-processing color. That's going to be uint32 underscore t color. We'll create its definition. So we need to go m underscore ndc vertices dot color equals color with a capital C equals color. So do that for, I've only got 4 vertices, we need to do that for all 4 vertices. And we'll just shift this update up here. Alright, now if we go to our main function, we need to create a variable to store our post-processing color. So we go glm vec4 post-processing color, set it to 1, and inside of our window we'll go if ImGUI color picker 4, call it post-processing color, and we'll go glm value pointer, which we need to include the extra I can never remember where it is. Give me one moment, I can never remember where this header file is. And it's called type. There we go, type pointer. So now that we can go value pointer, give it the post-processing color variable. Equals true. Alright, now we need to convert the post-processing color that's given to us from ImGUI into a 32-bit integer. So we need to go uint 32 underscore t new post-processing color equals uint 32 underscore t post-processing color dot a times 255.0, shift it 24 bits to the left, and then we need to OR it with the red color, sorry, with the blue color, and it's going to be shifted 16 bits to the left. Do the same thing for the green, that's going to be shifted 8 bits to the left. And finally with the red, but that doesn't need to be shifted at all. And finally we'll need to set the post-processing color. with our new color. Alright, so we'll run that. So here's our window with our color picker, and we can adjust the color, the post-processing color. So what is going on here? Well, the color picker takes in a color as 4 floats, one for the red, one for the green, one for the blue, and one for the alpha, and they are all in the range of 0 to 1. Now the colors that we use are an unsigned 32-bit integer, so we need to take each of the floats. So up here we've defined it as 4 floats, and we need to convert them into one integer. So we take each one, we multiply it by 255 because that's the maximum each color can have. Then we convert them to an 32-bit unsigned integer and shift the bits to the right place. We need to shift them because converting them to an integer will cause the number to occupy only the 8 least significant bits. But the alpha, for example, is in the 8 most significant bits, so we need to shift them. So if we just converted this alpha to 255, it will occupy the 8 least significant bits, so the bits on the right hand side. So we need to shift it 24 spaces to the left, and then we need to OR it with the blue, shift it 16 bits, with the green, shift it 8 bits, and finally we can just convert the red to 255, and they'll occupy the least most significant bits. And the result is one color with all 4 components that we use as our post-processing color. So that's it for this video. I'm going to push everything to GitHub, and in the next video we will be going 3D. So I will see you in the next video.